Problem 1. Lisa counted the sum of angles of a convex polygon. She missed one of the angles, and so her result was 20/20. What is the missed angle? So first we need to know the formula for the sum of angles of a convex polygon. The formula is here. Sum equals n minus 2 times 180 degree. And here is the number of sides for a polygon, which is an integer. So from the problem, we can set the equation is n minus 2 times 180 equals 20/20 plus x. Okay, so let's expand this equation and quickly solve for n plus x. So n equals, here. Okay, 20/20. Okay, so it's 2,380 plus x over 180. Okay, so as we remember, n has to be integer. So that means this 2,380 plus x should be divisible by 180. So also x has a range because this is a one angle of a convex polygon. So x should be in the range of 0 and 180. Okay, so let's do the division quickly. 80, 180. So 180, we have 58, 0. So we have 3, 540. So we have a remainder of 40. So n equals 13 plus 40 plus x over 180. So in order for 40 plus x is divisible by 180, also x in the range of 0 to the 180, so x equals to 140, which is the E. Problem 2. A sequence x1, x2, x3 is defined by xn plus 2 times xn and the plus xn plus 1 and equal to 1. For n is greater and equal to 1. Given that x1 equals 2, x2 equals 3, what is the value of x 20/20? Okay, so this sequence is defined by xn plus 2 times xn plus xn plus 1 equals to 1. Let's try to solve several terms. So for, of course, we know x1 equals 2 and x2 equals 3 already. So let's solve for x3. So xn equals 1, so we have x3 times x1 plus x2 equals 1. So we plug in, so x3 times 2 plus 3 equals 1. So we got x3 equals -1. Okay, so let's set n equals 2. So then we have x4 times x2 plus x3 equals 1. So we know x2 already, so which is 3. Then we know just solve the x3, -1 is 1. So we solve for that. So x4 is equals to -2 over 3. Okay, 2 over 3. So for the same way, we can get x5 times x3 plus x4 equals 1. So we plug in each number. So x5 equals to -1 over 3. We still do not see the pattern, right? So we have to try a few more. So n equals 4. So we have x6 times x4 plus x5 equals 1. So x6, equals 2. Okay, let's try one more, which is, this is n equals 4. Okay, n equals 4. So we try one more, is n equals 5. So we have x7 times x5 plus x6 equals 1. So for this time, we solve x7, x equals 3. Okay, so by this time, actually, you can find the pattern of this sequence. So we get x1, 2, 3, -1, 2 over 3, -1 over 3, oh, 2, 3 again. So it will grow like this. So we will have repeated this 5 numbers again and again. That's this sequence. Okay, so let's determine the value of x 2020. So x 2020, so because 2020, this term number is a multiple of 5. So that means it's repeated this 5 number 404 times. So comes to the last number, -1 over 3. So then we know x 2020 equals -1 over 3, which is B. Problem 3. A path of length 38 meter consists of 19 unshaded strips. Each of the length is 1 meter. And with 19 shaded strips, each length of 1 meter, just like this. Okay. So we have this strip, total is 38 meters. Okay, so then we have a circular well for radius is 2. Okay, divided into 4 quarters, which are alternately shaded and unshaded, just like this. And the well rolls at a constant speed along the path from the starting position showing. So this well makes exact 3 complete revolution. Okay, 3 complete revolution. So the question is, what is the percentage of time during which a shaded section of the well is touching a shaded part of the path? Okay, what is that percentage? So the percentage of a time, actually, because this well rolls at a constant speed, the percentage of time should be equal to the percentage of the distance. So let's calculate. Okay, so first, we got the circumference of the circle is 2 pi r. So 2 pi times 2 is 4 pi. So that means each section of 1/4 of the circle is a pi. Pi. So I draw 3 strips like this. Okay, analyze this situation. So 1 strip is 1 revolution of the well circle. And during this 1 revolution, actually we only have 2 shaded parts touch the strip, right? So I checked it here, blue check. So during these 2 intervals, we have all shaded area of the well circle, but we only have this shaded area with the strip. So this is 1 meter, so that is 3.14. So this is 0.14 meters, so total is 1.14 meters has been touched by the shaded part of the circle and the shaded part of the strip. So the same thing, we carefully calculate these numbers, and we same thing got it. This part is 1.42 meters. They touch to each other. And also for the second revolution, we also do the same way. Okay, so we got these 6 numbers. We add them together. So here is a 1.14. Okay, sorry. Okay, so we divide by 3 complete revolution. The distance is 37.68. So we calculated it's close to 26%. So the answer is E then, 26%. Problem 4. What is the largest positive integer k such that 3 power of k is a factor of 22 power of 10 subtract 19 power of 10? So we have the expression 22 power of 10 subtract 19 power of 10. And this expression could have some factor like 3 squared, 3 cubed, into 3k. So we need to find what is the largest possible integer k. So let's review some modular rules. So if A and C divided by B have the same remainder, so we write like this, and B and D divided by B has the same remainder, we also can write like this. So then A plus B and A minus B and C plus D and C minus B, when they divided by B, they should have the same remainder, and A multiplied by D and C multiplied by E. These two numbers, module divided by B, should have the same remainder. Then let's look at the power rule. So if we have a base A power of C divided by B, then should be, we need to find the remainder. So we can actually, we divide by B, use A, divide by B, find the remainder first, then raise to the power of C, then we module C again. So for example, we have 9 power of 2 divided by 5, and what is the remainder? That means module 5. So we can use 9 module 5 first, then square, then module 5 again. So 9 module 5, the remainder is 4 square, then module 5. So then 16, 4 square, 16 module 5. So the remainder equals to 1. So come back to our problem C, so we can do this. Let's first find is 3 is a factor of 22 power of 10 minus 19 power of 10. That means if this expression divided by 3, the remainder should be 0. Okay, so let's do, okay, 3 equals 22 to 10 minus 19 module 3 raised to 10. So obvious. So this one, 22 module 3 actually equal to 1 to 10, and the 19 module 3 is also 1 to 10, so it's 0. So that means the remainder is 0. That means 3 is a factor of 22 power of 10, subtract 19 over 10. So then let's try 2, 3 square, 9. Okay, so 22 power of 10, 19 power of 10 module 9 should be equals to 22 module 9 minus 19 module 9 and power of 10. So this equals to 3 and power of 10 minus 1 power 10, they're not equal to 0. So that means 9 is not a factor of 22 power of 10 minus 19 power of 10. So if 9 is not, so of course the 3 cube and the further won't be the factor of this expression. So we only have k only equals to 1. So the answer is A. Problem 5. We have 2 points on the coordinate plane A and B. A is 1, 1, and B is 4, 7. C is a point on the line segment connects AB. And 2AC equals BC, so means AC to the BC, the ratio is 1, 1 to 2. What is the sum of x coordinate of C? Okay, so let's say C coordinate is xy. Okay, so we draw the vertical line to the axis, okay, vertical line. And we draw the parallel line to the y-axis. So then we have the triangle, right triangle, BC, let's say, so this one is D, okay, this point. And this point, let's say it's E. Okay, BCD and BAE, they are 2 similar triangles. So let's set the equations. Okay, the first we have is BD over, okay, so first we have triangle BCD, similar to triangle BAE. Then the corresponding side, BD over BE, okay, equals to BC over BA. Okay, so as we know, BE, BD, so BE equals 7 minus 1, right? 6. And the BC is a 2, to the BA is 3. So we have that ratio, right? So we got the BD, which is 4. So then obviously DE is 2. So if the D is 2, then we got the Y coordinate of C, Y equals 1 plus 2 equals 3. Okay, first step. The second, also we use the similar properties of two triangle. We have CD over AE also equals to BD, also BC to AB. Okay, so CD, which equals to, okay, CD, so this is X, so 4 minus X, okay? So, this is X, yes, 4 minus X. And AE equals 4 minus 1. So BC to AB, 2 over 3. So when we calculated, we got X equals 2, 2, right? Okay, so our coordinate, C's coordinate is 2, 3. So we add 2 plus 3 equals 5. So our answer is B. Problem 6. ABCD is a rectangular closed napkin. Danica first folded B to B prime on CD along the crease AE. Then she folded it along B prime E and A prime B and CD with a meet at the same point F at AE. So from here, actually, we should know AB prime should equal to AB is length L. And we also know because these three angles, they folded to each other, they folded to each other, so they should be equal. So this is 30 degree, 30 degree, 30 degree. So then we have 30 degree, we have AB prime is length and AF, which is equal to AD, so it's W. Okay, so then also we find out the ADB prime is you fold it to the F, so these two angles should be equal, so it's 90 degrees. So then this is a special triangle, special right triangle. So we can find this content in chapter 7 in textbook. Okay, so this special 30 degree right triangle would have a ratio is 1 leg is 1 face the opposite side of 30 degree to the hypotenuse, the ratio 2, and the other leg is 3 square root. So let's just draw the triangle A, F, and B prime. Okay, so AF is a W and AB prime is L. So length to width, then the ratio equals to AB prime to AF, which is 2 to 3 square root. And the answer is A. Problem 7. How many 3-digit numbers are divisible by 14 and have identical hundreds and tens digits? So for 3-digit numbers have identical hundreds and tens digits, we will have 110, number like 110, and with the unit digits could be 0 to 9. Okay, 220, 330, 440, and 550. 660, 770, 880, and 990. Okay, so also these numbers are divisible, needs to be divisible by 14. So 14 divisible by 14, so we should be even number, divisible by 2 and 7. So even and 7. So let's try 110. So if we divide it by 7, we can easily get 112, which is divided by 7 and 2, same time. So which is divisible by 14. So because this number 110 to 119, only 10 numbers. So for the multiple of 14, you only can have one number. So we just have 112. Okay, so this one, yes. So for 220, we use the same way, and actually we find the 224 is also meets all the requirement. 336, 448. But for 550s, we only have 553 is divisible by 7, but which is not an even number. So it's not a multiple of 12. So this one, no. Okay, so these 4. And 665 is also not the even number. Okay, so it's not. So 770, 882, and 994. Okay, so we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. So total 7 numbers. The answer is C then.